Hey guys, welcome back to another video on the series on Microsoft Orleans. We're going to take a look at streaming in this video and how we can use streaming to optimize our application and avoid deadlocks and reduce coupling in our system as well. If you're enjoying the series, don't forget to subscribe to the channel, click the notification bell because we have a couple more videos in this series on Microsoft Orleans. And we'll have other video series coming up on other application and distributed application development topics. In Orleans, another way that grains can communicate and send to their data is through using streaming. This enables developers to write reactive applications that operate on a sequence of events in a structured way. Rather than relying on the request-response model that we've already seen in other videos, where grains call methods on each other and then wait for a response, using streaming allows us to decouple our grains from one another. Streams act in a similar way to virtual actors, where they have a unique stream ID and their creation or destruction is completely abstracted away from the application and developer. Essentially, they always exist. So in our example, say we add a new customer grain to our system, and we want this customer grain to store the, say, entire net worth of an individual across all their account types. The customer might have several accounts associated with them, and in this example, each account is represented by a grain. Previously, if we wanted to update the customer net worth, every time a balance in account changes, we'd have to make a direct grain-to-grain call to this customer grain from the account grain. And then we'd have to wait for the response from the customer grain. And if we're doing this a lot, this can lead to a lot of delays, or there can be deadlocks, different sort of consequences like that if we're using a grain-to-grain request-response architecture. With streaming, we can decouple this data passing by using a stream rather than direct calls. This means that our account grains push data onto a stream, which the consumer grain then consumes from. The consumer grain doesn't need explicit knowledge about where the events are coming from. As soon as it subscribes to them, it will just start receiving them. These streaming events are consumed in a similar manner to grain method calls. This means that they are essentially processed as grain messages, which gives it the same actor-based concurrency guarantees when using streaming. Another one of the advantages of using streams is that we can subscribe to this stream on other actor types, or other actors of even the same type. Say we add another actor type, and this needs the info from these account changes. In this case, we're adding an audit actor. We can simply plug this actor into the same stream. This makes our application flexible and helps us to reduce coupling, as the account grains don't need to know about the customer grain or the audit grain. We can even subscribe to streams from Orleans clients, which means that we can subscribe to these streams from outside grains. Like most functionality provided by Orleans, streaming is supported by pluggable stream providers which are backed by different technologies. Some providers supported officially by Orleans are Azure Queues, Azure Event Hubs, or Amazon SQS. I think it also supports Apache Kafka. I'll have to check that out and see what NuGet packages are available. Different stream providers provide us with different functionality, and we should be careful to choose the stream provider that best suits our application needs. Some stream providers support rewindable streams. These allow us to go back in time and look at messages that were previously published on the same stream. This even includes messages that were published before our grain existed. We won't be looking at rewindable streams in depth in this tutorial, as we'll be using the Azure Queues provider, which does not support them. However, if you're interested in using rewindable streams, then you might consider using the Azure Event Hub stream provider, which does support them. Rewindable streams can be really useful for recovery scenarios where we want to rebuild state from a specific point in the past. In terms of stream order guarantees and delivery guarantees, these also depend on the underlying stream provider we are using. Some providers support first in, first out order guarantees, while others do not. We can use the provided stream sequence token object on our stream to help us with ordering issues. Some providers also provide at most once delivery guarantees, meaning that we'll receive our event from the stream no more than one time. In certain scenarios, this might mean that we may never receive our event, because obviously no more than one time may also include 0. This again depends on the stream provider we're using. Others provide at least once delivery guarantees, which means that we'll be guaranteed to receive our message at some point, but we also might receive multiple copies of the same message. We need to design our application to process these successfully, and the choice we make depends on our application design and use case. So now that we know the basics of Orleans streams, let's look at how we can integrate them in our application. Okay, so we're back in our application here, our banking application. So let's go ahead and start to add some streaming. So like we saw in the example, we're going to stream from our account grains into our customer grain that we'll add in this video. So like we started with most things, let's start in our silo and let's configure our silo to support streaming. And the first thing we want to do there is install a NuGet package. So if we go to manage NuGet packages and we want to look up Orleans streaming, we want to install the Azure storage one because we're running Azurite. We're going to use the Azure Q Store to back our streaming. So we want to install that. So now we want to move to our program CS file in our Orleans silo. And this is where we want to add the code to actually configure our silo to support using Orleans streams. So we want to do that at the bottom here. So we want to say silo builder as usual, and we want to say add Azure Q streams. We need to give it a name. We're just going to call it stream provider. And we want to set up some options. So options builder. And inside here, we want to say options builder.configure. And we want to set up our client. So options.queueServiceClient, new queue service client. And in here, we just pass the same connection string for our development storage we used before. Perfect. So that's our stream provider set up to use the queue storage. Obviously, we would want to really, in reality, have this injected from a configuration file so we could easily change it to our production connection string. And one other thing in our silo that we need to do if we want to use Azure Streams is we want to store our pub sub stream data somewhere. So Orleans needs somewhere to store what grains are subscribed to what streams and different things like that. So we actually need to configure that as well. So after we add Azure Q streams, we need to do a .add Azure tables grain storage. So add Azure table grain storage, and we can use any storage for this. We've already used Azure table grain storage for our other storage providers, so we're going to use that here as well. And we need to call this pub sub store. And again, we just want to configure it with the same configuration that we used to set up our other table. So we can just copy it from the reminder service here. It should be the exact same, and it is. That's everything we need to do in our silo. We've installed a package, we've added the Azure Q streams here, and we've added the table store where we store our pub sub data. So what grains are subscribed to what streams. Okay. So now that we've done that, we need to move to the slightly more complicated task of configuring our grains to use streaming. And the first thing we're going to do is just add the event that we want to stream from our checking account grain to our customer grain that we'll add in a minute. So I'm going to add a new folder in the grains project and just call it events. And I'm going to add a new event called balance change event. And we'll make this a public record. We'll make sure it's serializable. And we'll add two properties to this. We'll add the checking account ID that the balance is changing on, which is a good. And we will add the new balance, which will be a decimal. Perfect. So once that's added, we want to actually start to add our customer grain. So we're going to start by adding the interface with the methods that we will be able to call on it. So customer grain. And the same as the other grains we added, we need to also implement the grain with GUID key or any of the grain interfaces here to make sure this works. We mark that as public, and we might want to add a couple of methods here. So what we're going to do is we're going to add a method to add a checking account to this customer. So really simple method, just adds a checking account. We don't need the public. There should be an interface as well. So really simple method, just add the checking account given the ID. And then we'll add another method, which will actually return a decimal. And this is where we want to get the full net worth of all the accounts. So we'll just call it get net worth. And that's it really for this interface. We don't need to do anything else. Pretty straightforward, just two methods. So now that we've got that interface defined, let's go ahead and create our customer grain. So in our grains folder, we just want to create a customer grain class. And we want to inherit from the abstract grain class provided by Orleans. And we want to implement our customer grain interface. And this grain is actually going to have some state. So let's create a state object to store our customer state. So we'll create a new class in our state folder and we'll just call it customer state. This will be similar to all of our other states. So we're going to make it a public record. We're going to make sure the state is serializable by adding a generate serializer attribute. And we're going to add the ID attributes to all our properties. And we're actually going to have one property here. We're just going to have a map of checking account ID to the balance in that checking account. So super simple dictionary of good for our ID and decimal for that checking account balance. We'll call it checking account balance by ID, getter and a setter, and we'll initialize it just to a new dictionary as well. Apologies. Perfect. We can get rid of the unused usings, and that is our customer state that we're going to store on our customer grain. So let's go back to our customer grain class. Let's make it public. Let's implement this interface, and let's add a quick constructor using the CTO or shortcut. And we want to actually inject our state here. So the same way we've always done. And remember, this is not a transactional store. This is just a normal store. We're not using transactions in our customer grain. Obviously, you can if you want to and if you can configure it correctly. But for us, we're just going to use the persistent state of customer state. I'm just going to call that customer state. And we need to add an attribute for persistent state here, giving it the state name, which we'll just call customer, and the storage name. And because we haven't set up a default store, a default persistent store to use across our grain, as you can see in our silo, we have a table grain storage called table storage available to us and a blob grain storage called blob. But we only have a default transactional store. We don't have a default normal persistent store. So we need to specify that we want to use table storage here. For this grain, we could use blob storage as well. That would be fine. And we've just forgotten to close our braces here. So perfect. So customer state. And as usual, we'll just store that in a private read-only variable, our persistent store. So persistent state, customer state. And we'll call that underscore customer state. And we'll just set that in our constructor. So now we should have access to read and write the state we want to change. And then we want to implement these two methods. So we'll start by implementing getNetWorth. We know we have a map of checking account balances by ID. So essentially what we want to do is you just want to sum all the values in that dictionary. So we've got customer state, checking account balance by ID, and we can just go values to get all the values, and we can just sum them together, and that should return our entire net worth. And we just need to mark it as async. Perfect. So that's our getNetWorth method implemented. So add checking account is where we want to add our relation between the checking account and the grain, and also where we want to actually subscribe to changes in that checking account. So in a few minutes, we'll go into the checking account and start to produce these events on that stream. But here we want to add our subscription to this stream as well. So when we add checking account to the customer grain, that's where we want to start consuming from the stream as well, or we want to add our subscription. So first thing I think we need to do is we just want to add a entry into our dictionary in state to say that this checking account has subscribed, and we'll default it with a balance of 0 to start with, say. So customer state checking account balance.ie, and we want to add the checking account ID with a default balance of 0. Again, no error checking here. If you're doing this in real life, definitely require some error checking here to make sure you're not adding duplicate keys, different things like that. But for the sake of brevity, I will leave that out. And then we just want to write that state. So we want to say customer state, write state async. Perfect. So we've got two parts now. So we want to add the subscription in the add checking account method, which we'll do in a few minutes. But we also want to write the logic for when we receive one of these events, what we do. And to do that, we want to add the iAsync observer interface, or we want to implement the iAsync observer. And we need to give this a generic type. And we don't have any reference to this because I never added the necessary NuGet package. So we want to add the streams NuGet package into our grains as well. So if we right click on grains, manage NuGet packages, and just search for Orleans streams, and we can install Microsoft Orleans streaming. And now we should have access to this interface once that's installed. Perfect, using Orleans streams. And in the generic here, we just want to give the balance change event. And we can go ahead and implement that interface. Again, to save some time, I'm just not going to implement on completed async or on error async. I'm just going to return a task.completed task for now. In a real situation or a real production application, obviously you'd want to implement these correctly. But what we're really interested in is the onNext async method, which is where we actually receive the balance change event in our customer grain. So this is where we want to write the logic to update the customer state for the given account with the latest balance. So first thing we might want to do is you just want to retrieve that map from this store, so that dictionary from our customer state store. So that's going to be checking account balances by ID, and that's in our customer state check account balance by ID. Perfect. And then obviously we know we're going to update something here. So before we forget, let's just write it at the end of our method and implement the actual logic in the middle. So really what we want to do is we just want to check, does the checking account already exist in the dictionary? If it does, we want to update the balance. And if it doesn't exist, we want to add it. I think we can be relatively confident that it will always exist because we've added it in the add checking account, and that's where we add the subscription. And we won't receive any events from accounts we haven't subscribed to. But just to be absolutely sure, we'll do an if checking account balance by ID contains the item dot checking account ID already. Then we want to update it to be, we want to update the checking account ID to be equal to the new balance. Perfect. And if it doesn't exist, we want to add it. So I'm not sure this logic in the else will ever get hit, but if it does, we will essentially get the same functionality. So we just want to follow that there. So that was pretty quick. So let's just go through it again. From the customer state that we just added, we get the checking account balances by ID. And we're just simply receiving our event, checking if we already have referenced the checking account ID. If we do, we just set it to the new balance. If we don't, we just add the new checking account ID with the new balance. That's it really for our onNext async. Everything we want to do there is pretty straightforward. Nothing specifically related to streaming here except this method signature. We talked a little bit about the stream sequence token in the intro. This is where we would actually have access to the sequence number if we wanted to control if we were processing messages in order. We might need to do something a little bit more fancy with that, but we're not going to do anything like that right now. Okay, so let's jump back to the add checking account method. And this is where we want to actually add our subscription to a specific checking account. So to do that, we need to get our stream provider. So the stream provider is what we added in the silo. So we can say simply this get stream provider, and we need to give the stream provider name. And the stream provider name is just what we added in our configuration. So it's just stream provider. Let's copy that in there. And then we want to get the stream ID that we want to subscribe to. So we can store this in a variable called stream ID. And essentially what we want to do is we just want to do stream ID.create. And we want to give this stream a name. So let's call it balance stream. And then we want the ID that we're subscribing to. So the ID of the grain. So this will have to be mirrored when we're actually producing messages. So we'll also use the same stream name and ID, which is the grain ID. So once we have that stream ID, we can then get the stream. We can say stream equals stream provider. And we want to say get stream. We know what the event type is. It's balance change event. And we know what the stream ID is, just the stream ID. So that will get us the stream. And then we simply say stream.subscribe async. And inside the async, we need to pass an async observer. We already have an async observer. Our grain is essentially an async observer. So we can just pass the instance of our grain into this. And we can just say, that's it. So now we should be set up to consume these balance change events from our stream. Let's get rid of a few of these usings. There's one thing we need to do here else, but we'll jump back into this class in a minute, and that's to do with error recovery. But let's go into our checking account grain and actually start to produce messages on the stream that we've just added the code to consume from in our customer grain. And a lot of this will be very similar to what we did in our customer grain. We'll just call one or two different methods. I think the best place to add this is in our credit and our debit method. So this is where the balance of a customer's account actually changes. So after we did the transaction, maybe it's a good place to put them for now. And we want to do something very similar. So let's close everything except our checking account grain and our customer grain. And we'll copy over this because we'll more or less want to do the exact same thing here. We'll just do it slightly differently. So in our credit method, we still want to get the stream provider, get the stream ID, but in this case, we don't have the checking account ID variable, but what we want to use and what we know we want to use is the grain ID. So we can say get grain ID, get GUID key, which will be the same. And then we get our stream in the exact same way that we got it when we were consuming. But in this case, rather than consume from the stream or add a subscription, we want to say await stream on next async. So this will push a message onto the stream. And we can just, as you can see here, pass a balance change event. And we can also pass that stream token, which we're not going to do here. So we'll just say new balance change event. New balance change event. And in our balance change event is where we want to add our ID for account ID, which again will just be the same as our grain ID. And also we want to add the balance. And we know the balance is just going to be the same as the balance, which we can call by calling the get balance method. Perfect. So that should produce this balance change event onto our stream. And that's it, really. We can just copy that. We want to do it on the debit as well. Really simple. There's actually no difference here at all. The balance is the balance, whether we debit or credit. Obviously, this is a good opportunity to abstract some of this code into a private method. I'm not going to do it here, but maybe something you would want to do in a real application. So rather, that's everything we need to do in our checking account grain. We mentioned something small we want to do in our customer grain around error recovery. And this is because if a grain gets deactivated and reactivates, we need to resubscribe to our subscriptions. This doesn't happen automatically at the moment. So what we actually want to do is we want to override the onActivate async method and resubscribe to the streams that we previously subscribed to. And we were smart before because we stored everything we wanted to subscribe to in this mapping dictionary with the balances. So we can simply just loop through that dictionary that we have in state and resubscribe to everything. Should be pretty straightforward. So let's say public override async ask on activate async. And that takes a cancellation token. Perfect. So what we want to do in here is, again, we want to get our stream provider. And then essentially for every account ID, we just want to loop through them and we want to add the subscription again. So we can just say checking account ID in, and this is going to be in our customer state. And in this case, it's not the values, which is the balance, it's the keys that we want, which is all the checking account IDs. And then inside this method is where we want to re-add the handlers. We don't need to resubscribe, we just need to re-add the handlers. So we want to get the stream ID and we want to get the stream, and then we want to get the handlers. Await stream, get stream subscription handles. Shouldn't be called handlers, should be called handles. Equal sign. Simple. And then we just want to loop through these handles for handle in handles. And we can just say await handle, handle.resume async. And again, we want to pass in an async observer, which again is just the grain that we have created here. Perfect. So I believe that's everything that we need to do in the grains project. So it was quite a lot there. Appreciate that took a little bit of time, but we've set up our subscription now. We've set up our production onto the stream. We've set up our silo to actually support it. It would be a lot simpler if we wanted to consume these events from another grain. We would just have to add the subscriptions. We wouldn't have to re-add the publishing. So next, let's go into our client. Let's add a couple of method calls to trigger these subscriptions. Okay, so the last thing we'll do is configure some API methods on our client. We're going to have two API methods, one just to get the customer net worth, and the other to add a checking account to a specific customer. So we're going to need a contract to add that checking account to a customer on our API. We'll just call it customer checking account. Need to make sure it's serializable, obviously data contract with record, and we just need the account ID, I believe. Perfect. And we can then use that on our API. So let's go into our program CS class. We don't need to add anything in the use Orleans client. If we actually wanted to stream directly into the client, we would have to add some configuration here. But we're not going to do that in this video. We're only going to stream from grain to grain. So let's first add the get to get our net worth for a customer. So we're going to change the API to be customer and customer ID. Instead of balance, we call it net worth. We're obviously getting customer ID from the root. We do not need a transaction client anymore. We need the cluster client still. So let's remove that and that. We don't want to get the ATM grain. We want to get the customer grain. And we want to get the customer grain for the customer ID. And we want to call it customer grain. Perfect. Let's fix our indenting. So once we have the customer grain, we can just call it get net worth. Simple. And we can return that over the API. So that's it for the get. Very similar to the balance endpoints we've added, except this time we're going to the iCustomer grain instead of the ATM grain or checking account grain. Let's do the post now. So we want to post in this case because we're adding a checking account to a customer. So again, it's going to be the customer root with the customer ID, and we'll just call the endpoint add checking account. We don't need the transaction client again because we're not using transactions here. And we obviously don't want to use the ATM withdrawal contract on the API. We want to use the customer checking account one. So just change that, and we'll change the variable name as well. We can delete all of our transaction code here, but we might want to return a typed result of no content if we're successful. Perfect. And inside the actual method, let's just get the customer grain the same way we got it on the get. And we know we want to call the method add checking account. And we have the checking account ID as well from the customer checking account object, which is just called account ID. And we want to await that as well. So I believe that's it from the client point of view. We should now have everything set up to stream correctly. So just to summarize very quickly, what we're expecting to do is when we create an account, we can then add that account to a customer. The next time the account balance changes, that will get streamed into the customer, and then they will have that account balance updated as part of their net worth. Obviously, a couple of optimizations you could make here in that when we first add a checking account to a customer, we're not actually updating the balance. It will remain as zero until the balance on the checking account changes, which isn't great. Another small thing to point out is that we're not actually explicitly initializing the customer grain in a special initialize method. It's not really necessary. We just initialize it essentially the first time that we want to add a checking account. And that's us taking advantage of kind of virtual actors and the fact that they are already there when we want to add a checking account to a customer, even if we haven't explicitly already used that actor or grain before. And one very small thing that I realized that we did wrong is on the balance change event, we need to make sure this is serializable in the same way that our state is serializable. So unlike an API contract where we can use data contract and data member, here we do have to use generate serializer and specify the IDs, especially if this is involved in methods that use transactions. So it's safer just to say ID1 and ID0 here when we're adding events to be streamed. All right, so let's try this out. Let's try to stream some messages to our customer grain. Obviously, before we start our cluster, just make sure you have Azurite running as usual. And let's just start it up. Make sure it starts successfully, and then we'll jump into Postman and make some requests to our cluster just to see the streaming in action. So if we open up Postman here, I've added a couple of new calls to our collection to make this work. First thing we're going to do is we're just going to create a new checking account. So brand new checking account with a balance of 500. Get the ID as usual from the response headers. And we can just double check on our get checking account ID / balance that we do indeed get the 500 balance back. Great. And then we want to add that customer account to our customer. So we want to copy the account ID into the body. And then we can just use any new GUID as part of the root parameter for the customer ID. So the account ID is what we got back from the initialized checking call, but the customer ID can be any random GUID here. So I'm just going to use this one I used earlier, but I'm just going to change a few small things to make sure this works. So I'm going to send that, and that will then add the subscription from this customer to that account to start streaming data. So we'll send that. We got no content. And what we will now do is we will just copy the customer ID from the URL into the get customer net worth API endpoint. So it's just customer / customer ID / net worth. And we get a net worth of 0. And obviously, as I explained earlier, this is because we don't stream the initial balance at the moment. We just stream balance changes. So if we go back and get the account ID, and if we debit that account, so let's debit it by 50, we'll send that. That should stream that 50 balance change into our customer. And it was a debit. So I think the account net worth should now be 450. Perfect. That's what we got. Let's just go one more time. Let's add another account and let's stream something from that account again into this customer object. So we will create a second account, but this time with a balance of 10,000. Here it is here. Get the check account ID, and we want to add that account to the same customer ID. So these two subscriptions now to this one customer. So we'll create that. And if we get the customer net worth, again, it will still be 450. But as soon as we change something in that second account ID that we added, so let's credit it by 5,000. So then we would expect the net worth, so the account balance will be 5,000, but the net worth should be 5,450, because it's the combination of both of the accounts that are related to that customer. So we'll send that and we'll check the net worth, and we can see, I think I got my number slightly wrong, but it's the combination of the two accounts, and both those events are being streamed successfully into the customer grain. So thanks for watching this video on streaming. Appreciate it was probably slightly long, but I think it covered most of the aspects of streaming in Orleans. Codebase is obviously available on GitHub, and hopefully the Postman collection will be there as well in the description. If you're enjoying this series on Microsoft Orleans, you want to see more of it, or you want to see other videos on distributed application development, don't forget to like the video, subscribe to the channel, and hit the notification bell so you get notified when new videos go up. In the next couple of videos, we're going to look at some slightly smaller aspects of Orleans, so looking forward to seeing you there.